Hello everyone. Today we are going through chapter 5. Chapter 5 is on statistical inference. In this chapter, you have to know and you have to learn on how to conduct 4 types of statistical tests. The first test is called one sample hypothesis test. The second test is called two sample hypothesis test. The third test is called ANOVA test. And the last test, or the fourth test, is called chi-square test. So we will begin with one sample hypothesis test. So at this stage, I'm pretty sure you already know how to differentiate between a populations and a sample, because a one sample hypothesis test involves only one population. If you are using two populations, you are not supposed to use a one sample hypothesis test. So again, one sample hypothesis test is used when involving only one populations. Let's see, for example, from the populations here, which is consisted of individuals being quarantined for COVID-19, we want to take a sample to test whether these individuals are mentally unstable or not during the period of quarantine. So we are making a test on the populations based on a sample that we draw from the populations. Steps involved in one sample hypothesis test. There are 5 standard tests or 5 standard steps or 5 steps that you have to make it clear when you are doing one sample hypothesis test. First, the first step is you need to write down the hypothesis. So I'm pretty sure in the lesson that we have learned previously last week or the week before last week, you learn how to write the hypothesis from a statement. Given a statement, you should be able to write what is HO or what is null hypothesis and what is the H1 or what is the alternative hypothesis. The second step, once you have done with the hypothesis, is to choose a significance level. A significance level can be, for example, 5%. There are 3 significant levels: 5%, 10%, and 1%. Step number 3 is to select your test statistic. Your test statistic can either be a z-test or a t-test. When to use a z-test and when to use a t-test, we will look into that later. Step number 4 is to make a decision. So based on your z-test or based on your t-test, you should be able to make a decision whether to reject or whether not to reject the null hypothesis. Once you have done with your decisions, you make a conclusions. So those are the 5 steps involved in one sample hypothesis test. So we move, let's say you have formulated a hypothesis and you have select your significant level. Let's move to step number 3. Step number 3 is to decide on your test statistic. In general, there are 2 types of test statistic. The first test is called one sample test for mean when the sigma is known. Sigma is the population standard deviation. The second test is called one sample test for mean when the sigma is unknown. So you have no idea what is the population standard deviation. So you can either choose the two tests, depends whether you can identify the population standard deviation or you are not able to identify the population standard deviation. Okay, the first test statistic is called a z-test. A z-test is used when the population standard deviation is known. If you are able to identify the population standard deviation, you should use the z-test. The formula for z-test is given here. So z-test equal to x bar, or the sample mean, minus the hypothesized mean divided by the population standard deviation divided by the square root of the sample size. So this is the z-test, and remember, you can only use the z-test if you know the population standard deviations. If the population standard deviation is not known, you should use what is called the t-test. So the formula for t-test is equal to, it is quite similar with the z-test formula. The t-test formula is the sample mean, or it is denoted here as x bar, minus the hypothesized mean divided by the sample standard deviation divided by the square root of the sample size. So if you can notice, the difference between the z-test and the t-test is on the sample standard deviations, because t-test, the formula used the sample standard deviation, whereas for the z-test, the formula is using the population standard deviation. Okay, once you have calculated your t-test, you should be able to decide whether to reject the HO or you cannot reject the HO. So this is step number 4. Once we have the test statistic, we need to make a decision. Our decision is whether to reject the null hypothesis or do not reject the null hypothesis. In order to know whether you can reject or you cannot reject the null hypothesis, you should use either the critical value approach, which is called the Z value or the T value, or the P value approach. So there are two approaches to know whether you should reject the HO or you cannot reject the HO. It is either by using the critical value approach or the p-value approach. Okay, once you have the test statistic, the test statistic value is derived from the z-test or the t-test that we have conducted from step number 3. So once you have that value, compare the test statistic value with the critical value. So that is a formula to calculate the critical value. Or if you want to use the p-value approach, you should compare the p-value with the significant level. And this is called p-value approach. So remember, there are two methods that you can use to make a decision making on whether to reject or not to reject the HO. So the first method is known the critical value approach, and the second method is known the p-value approach. Okay, critical Z value. So remember how to calculate the critical value? The critical value here Okay, critical Z value. Critical Z value is used for one sample test for mean if the population standard deviation is known, meaning that Z value is using the standard normal distributions and you should find the critical Z value. Actually, the critical Z value can be located from any statistical textbook, but you can actually use Microsoft Excel to calculate the critical Z value. Critical T value. If the population standard deviation is not known, you should use the critical T value. Critical T value utilizes the T distribution table, and the critical T value can be found from the table from any statistical textbook. But again, we can actually calculate the T value from the Microsoft Excel formula. That we will look into that in the next chapter or in the next PowerPoint presentations. Okay, now, critical value two-tailed test. You should be able to know how which test should be used in order to conduct your one sample hypothesis test. First, look at the hypothesis that you have formulated from step number 1. In order to know which critical value that you should use, is it is it two-tail or is it one-tail? It depends, again I repeat, it depends on the hypothesis. If you have a hypothesis such as a null hypothesis with a sign of equal and an alternate hypothesis with a sign of not equal, meaning that you should apply a two-tailed test. This is how a two-tailed test will look like. Here is the rejection region and here is the rejection region, meaning that there are two rejection regions on the left and on the right. So this is the critical value point, and this is also the critical value point. The second test is called lower one-tail test. How do you know whether you should use this lower one-tail test? Again, it depends on the hypothesis that you have written in step number 1. So if you have a null hypothesis with a sign of greater or equal than and a research or alternate hypothesis with a sign of less than, then straight away you know that you should apply a lower one-tail test. Lower one-tail test has a rejection region on the left or on the negative side. So look here, give an attention on your alternate hypothesis. The sign used in the alternate hypothesis is less than. Less than meaning it is negative. Since it is negative, it should be on the left hand side of the tail, and you will straight away know that you are using or you should be using a lower one-tail test. And this is the critical value cutoff point. Okay, then the last test is called upper one-tail test or critical value upper one-tail test. So when should you use this upper one-tailed test? Again, look at the hypothesis. If you have a null hypothesis with a sign of less or equal than, and an alternate hypothesis with a sign of greater than, straight away you know that you should be using an upper one-tailed test, meaning that the rejection region should be on the right side of the tail. Look at your research hypothesis and what is the sign used in your research hypothesis. Here, the sign used is greater than. Greater than meaning that it is on the positive side of the tail. So straight away, you know that the test used for this hypothesis should be the upper one-tailed test. Or in other words, the rejection region should be on the positive side of the distribution. Okay, we end our lesson for today by looking at the example on how to write a hypothesis and which test should you use based on the hypothesis. Okay, let's say you have a statement, the average IQ of the female adult population is at least 100. A researcher believes the average IQ of female adult is lower than 100. So what is the research hypothesis? What is the statement that the researcher want to test? Definitely, the statement is here. The statement that to be tested is the average IQ of female adult is lower than 100. So straight away, you know that the research hypothesis or the statement to be tested is the average IQ of female adult is lower than 100. So your H1 should be the hypothesized mean. The hypothesized mean in this example is 100. So H1 is hypothesized mean is less than 100. Whereas your null hypothesis or HO should be the hypothesized mean is greater or equal than 100. So your null hypothesis is based on this statement. This statement states that the average IQ of female adult population is at least 100, meaning that it is not less than 100. So your HO should be more or less than 100. So which test should you use for this type of hypothesis? Again, refer to your alternate hypothesis, the sign used for your alternate hypothesis. So the sign used here is less than. So if you refer back, if you have an alternate hypothesis with a sign of less than, the test should be a lower one-tailed test. So based on the hypothesis sign in H1, which is less than, we know that the test is a lower one-tailed test because the symbol less than is a negative sign and should be on the negative side of the tail. So that is all for today. Next, I would like you to try on the example or the exercises on how to write down hypotheses, and then you decide on which test that should be applied for that type of hypothesis. Is it going to be a two-tailed test? Is it going to be lower one-tailed test? Or is it going to be upper one-tailed test? So thanks a lot and selamat berpuasa.